Yes, there should ideally be a gap between the first and last turns of a toroidal coil. While it is physically possible to wind the wire 360 degrees around the core, best practices in electronics recommend leaving a 30-degree gap occupying only about 330 degrees of the core. Thanks a lot VO2TDD for mentioning this important point which I was not aware of till then. This gap serves two primary technical purposes. One, reducing parasitic effects, and two, preventing electrical failure. Regarding the first point, minimizing parasitic capacitance. When the first and last turns are placed right next to each other, they create a high voltage differential point. Inter-turn capacitance. Every turn of a coil has a small amount of capacitance between it and its neighbor. However, the voltage difference between the first turn and the last turn is the total voltage across the entire inductor. Self-resonance. If these two ends are too close, the high capacitance between them can significantly lower the self-resonant frequency of the inductor. This causes the component to act like a capacitor rather than an inductor at higher frequencies. From the safety point of view, preventing voltage breakdown or arcing is also very important. If you are winding a transformer or an inductor for high voltage applications, the insulation or enamel on the wire is the only thing preventing a short circuit. Insulation stress. Adjacent turns only have a small voltage difference between them, which the thin enamel can easily handle. Arcing risk. Because the first and last turns represent the maximum voltage potential of the coil, placing them side by side puts maximum stress on the insulation. A small scratch or a voltage spike could cause the insulation to fail, leading to an internal arc over and destroying the component. Here is a comparison of winding techniques. Regarding inductance, 360 degrees full winding will have slightly higher inductance per core volume, and 330 degrees winding with 30 degree gap will have standard calculated value. Capacitance. High due to start and proximity for 360 degree full winding. Low minimizes capacitive coupling for 330 degrees winding with a gap. High frequency performance. Poor performance with 360 degree full winding with lower self-resonant frequency. For a 330 degree winding, high frequency performance is better, maintains inductive behavior. Safety. High risk of arcing at high voltages for 360 degrees full winding. For 330 degrees winding with a gap of 30 degrees, there is a low risk and physical separation provides safety. As a practical tip, try to space the turns evenly around the 330 degrees arc. If you find you have too much or too little wire as you approach the end, it is better to slightly compress or expand the spacing of the turns rather than closing the 30 degree gap. You can adjust the final inductance of the coil slightly by spreading or squeezing these turns once they are on the core.